Hello friends, welcome back to the another video lecture of ADA subject. In this video lecture we are going to learn about your fourth unit, which is dynamic programming. So in this unit we will learn introduction of dynamic programming. So dynamic programming is invented by a US mathematician Richard Bellman in 1950. And keep in mind that this dynamic programming word is not stand for programming. So it does not mean by computer programming. We will understand different programming technique solving problem with overlapping sub-program. So it will be a simple, we can say, mathematical procedures. It will not be a computer programming. In this method, each sub-problem is solved once only. The result of each sub-problem is recorded in a table from which we can obtain a solution to the original problem. In short, if in our problem we have some different sub-problems and that sub-problem are repeating more than once, so each and every time we will not solve that sub-problem, but we will keep its record into a table and we will use it tables data for our problem solution. Okay, so this is a dynamic programming. Let's understand by it an example. For example, our problem is finding solution of Fibonacci series. So all of you know that Fibonacci series is a method by which we can find third number by adding previous two numbers. So here we have Fibonacci series 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55 up to n. So in that we will have f0 and f1 already. By these two numbers we will generate our Fibonacci series, and in equation will be fn is equal to fn minus 1 plus fn minus 2. So if we want to find f2, then our equation will be f0 plus f1. Okay, so this will result like this. If we want to find our f2, then we will need f1 and f0. So f0 and f1 will proceed with f2. If we want to find our f3, then we will need f2 and f1. So we will add f2 and f1, we will make our f3. If we want to find our f4, then we will need f3 and f2. So here we will not calculate f2 again. f2 will from f1 and f0, but we will not calculate this thing again. We will store into a table. This f2 we will store into one table, and from it we will find the value of f2 and directly use here. If we want to find our f5, then we will need f4 and f3. So in that case f3 we have already calculated here, so that thing we will store into a table, and here we will directly use our f3. We will not calculate this thing here. So this is an example of our dynamic programming. If we want to find our f6, so we will need f5 and f4. So we will not calculate f4 again because our f4 is already calculated. So we will store f4 into a table, and from it we will find its value and we will calculate our f6. So this is an example of dynamic programming. Okay, so I hope you will understand that what is dynamic programming exactly. So now let's understand difference between divide and conquer technique and dynamic programming. So let's start with our divide and conquer technique. So divide and conquer technique is a top down method, and while our dynamic programming is bottom up technique. We usually start with the smallest and hence the simplest sub instances. Okay, in divide and conquer technique, the sub problems are independent of each other, while in dynamic programming the sub problems are not independent. Divide and conquer does more work on the sub problems, while dynamic programming solves the sub problem only once and then store it in table. Here divide and conquer technique has more time consumption, while dynamic programming will have less time consumption. Divide and conquer technique splits its input at specific deterministic point, usually in the middle. You know all that we have already always find middle point, means low plus high divided by 2, and we will find mid, and we will split that by the midpoint. But dynamic programming splits its input at every possible split points rather than its particular midpoint or particular point. Okay, so after trying all the split point, it determines which split point is optimal. Okay, so this is the basic difference between dynamic programming and divide and conquer technique. In most of the exams this question will be there, so keep in mind that this is the IMP question for exam purpose. Okay, so this is the introduction part of dynamic programming. In next video lectures we will know what is optimal solution and how we can solve different problems by our dynamic programming. So if you like this video, then like, comment and subscribe. Also share it with your friends. Thank you friends.